Good day, grade 12 learners. Welcome to today's physical sciences lesson brought to you by the Gauteng Department of Education in conjunction with Saibono. My name is Bongani Mabuya and I will be with you throughout this lesson. Today we are going to deal with paper 1. Specifically, we are going to talk about Newton's second law. So that is the topic of the day, grade 12s. It is Newton's second law. And the reason why we do Newton's second law is because this content in grade 12, it is examinable. Your question 2 of paper 1 is Newton's laws. So it is very important that we make sure that we are comfortable with Newton's laws. So that's what we'll be doing today. We are going to deal with Newton's second law. We will be drawing free body diagrams and force diagrams, and we will be performing calculations. So as I have alluded to you, that for physical sciences, you are going to write 2 papers at the end. Paper 1, which is physics, and paper 2, which is chemistry. So now we are still focusing on paper 1. So paper 1, it will be out of 150. The first section is section A, multiple choice question. You'll get 10 multiple choice questions. And then section B, it will be structured questions from question 2 to question 10 or question 11. And the total is 130 marks. So for paper 1 in total, you will be writing for 150 marks. And the duration is 3 hours. So I have alluded to you that today we will be talking about Newton's second law. That's what we'll be talking about. And it stems from the knowledge area of mechanics. And mechanics, we know that it weighs about 65 marks. So mechanics topics for grade 12, they are Newton's laws, vertical projectile motion, momentum, and work energy and power. And the other topics for paper 1 which are covered, it's waves, Doppler effect. That's the topic that we'll be doing in grade 12. Matter and material. you'll be doing photoelectric effect. And then for electricity and magnetism, we will be doing electric circuits and electrostatics. And these ones, we are going to cover them as well later. So that is what we are going to talk about today, Newton's laws. And from grade 11, you know that there are 4 Newton's laws. Newton's first law, Newton's second law, Newton's third law, Newton's law of universal gravitation. So it is important to be in a position to state all of these laws because they are examinable in grade 12. But today we are going to pay specific attention to Newton's second law. So we know that when we talk about Newton's first law, we are talking about the law of inertia, where we are saying that the object that is at rest will continue to be at rest or move at constant velocity unless an unbalanced net force acts on it. That is Newton's first law. And then Newton's second law, which is what we are going to talk about, is the one that states that when the net force acts on an object, the object will accelerate in the direction of the force. Acceleration is directly proportional to the force and inversely proportional to the mass of the object. Then later, you will be in a position as well to discuss Newton's second law in terms of momentum. So this is where you'll also bring the issue of impulse. Then Newton's third law. What's important about Newton's third law? It is to be in a position to identify action-reaction pairs. So if you can be in a position to identify action-reaction pairs, then you are winning. Now, data sheet. This is very important. We are here to make sure that we win when it comes to physical sciences. And our objective it is to pass physical sciences well. And you will notice that the tone of the day, it's about the data sheet. That copying a formula from a formula sheet is a skill. It is a skill. Copying a formula from a formula sheet, it's a skill. So as a grade 12 learner, you should be in a position to extract the correct formula and substitute correctly. So for Newton's laws, we deal with only this part of the section under the data sheet that says forces. And then you should be in a position to choose the correct formula. So using the correct formula, it's a skill. And formula sheet will be provided to you when you are being assessed. So it is important to use it correctly. Copying a formula from the formula sheet is a skill. So you should be equipped in ensuring that you pick the correct formula. So that is what we are going to talk about today, Newton's second law. And Newton's second law, it tells us about the relationship between net force, acceleration, and mass. So that is what we'll be talking about, that triangle relationship between the net force, acceleration, and the mass of the object. So that is what Newton's second law is about. And bear in mind that we have not yet started. I'm still greeting you in the name of Newton's second law. We'll get to the topic of the day. So our weapon, it's the exam guideline. It is very important that as well as educators, we use the exam guideline. And as well as a learner, you should use the exam guideline. The exam guideline, it provides a map. It gives us the information. What is it that you need to know about Newton's laws? So it's very important to associate yourself with the exam guideline. You must be familiar with the exam guideline of 2021. So the exam guideline, it tells you that for Newton's laws, you will be assessed on your comprehension of Newton's laws and their application. So that is what you need to know, is that you must know how to state Newton's first law, Newton's second law, Newton's third law. And you should be in a position to do what? To provide application of these laws. And this is what I'm saying, that with Newton's second law, we should be in a position to state Newton's second law and also be in a position to do what? To perform calculations. So that is what we are going to do today. State Newton's second law, draw a free body diagram, perform calculations. So the exam guideline, it guides us that what is it that will be assessed on Newton's laws. It is your comprehension of the definition itself and its application. So, Newton's laws, it has to do with forces. So as a grade 12 learner of 2022, you should be in a position to identify the type of forces that act on an object. Because once you are in a position to identify the types of forces that act on the object, then it becomes easier for you to perform calculations. So we need to associate the types of forces with Newton's laws. And the exam guideline, it tells us that you should know the different kinds of forces that act on the object. And what is fundamental as well, it is to use the correct symbols when we draw the free body diagram. So forces can be weight, normal force, frictional force, and applied force in terms of push or pull and tension on the strings. So you should be in a position to identify the types of forces that act on an object. So I want to rephrase this to you, that we are going to associate the types of forces with Newton's second law. That is what we are going to do. That is our focus today, that we should be comfortable with Newton's second law. And it tells us, the exam guideline, that define normal force. I had to put this strategically because I've noticed that lately when it comes to assessment, the exam, they usually require you learners to define normal force. And it becomes a challenge for learners to define normal force. Not because you don't know what normal force is, but you don't know how to define it. So the exam guideline, it tells you how to write down the definition of the normal force. And we are going to use the definitions the way they are written from the exam guideline. And when it comes to definitions, it's 2 marks or nothing. It's very important that we write the definitions the way they appear from the exam guideline. Not from our own narrative, not from the textbooks that we use, but from the exam guideline, because that is the common ground. Even if me and you, we argue, at the end of the day, our referee is going to be the exam guideline. What does the exam guideline say? So you should be, and you need to train yourself to make sure that you seeing the definitions the way they appear from the exam guideline. So seeing definitions, it should be your norm. Seeing them the way they appear from the exam guideline. So the exam guideline, it tells us how to define the normal force and how to represent the normal force. The symbol for normal force is N. It says define the normal force as. I love this. So it tells us that you need to define the normal force as. So it does not give us an option to search for an alternative definition. It tells us this is how we need to define the normal force. It says define the normal force as the force which a surface exerts on an object which it is in contact with and which is perpendicular to the surface. That is what the exam guideline is saying. So this is how we must define the normal force. We must define the normal force as the force which the surface exerts on an object with which it is in contact with and which is perpendicular to the surface. I love this definition. I love this definition. And it is not only restricted to question 2. As well in question 5, we do find this definition. So I am going to give you 1 minute to sing this definition to yourself. Normal force is the force which a surface exerts on an object with which it is in contact with and which is perpendicular to the surface. So this should be your norm to see the definitions the way they appear from the exam guideline. So this is merely a tip to say that a normal force, it is a frequent question that is being asked. More especially if you look at the question papers 2019, 2020, 2021, you'll find normal force. And we need to be in a position to use the exam guideline as well the diagnostic report so that it informs us what is it that we need to emphasize to you all the time. So we are saying that define all the terms the way they appear from the exam guideline. And when it comes to definitions, it's 2 marks or nothing. So define the way they appear from the exam guideline. So it says define normal force as a force which a surface exerts on an object and which is in contact with and which is perpendicular to the surface. So we need to understand that the normal force is perpendicular to the surface. So let us write definitions the way they appear from the exam guideline. I love what I'm saying. I love it. I love it. I love it. I love it. Define frictional force, and you are given the symbol. This is the acceptable symbol for frictional force. So define frictional force as the force that opposes what? The motion and acts parallel to the surface. So this is how you should define frictional force. That it is the force that opposes what? The motion. And it acts parallel to the surface. And it acts parallel to the surface. And there's a reason why they say, and it acts parallel to the surface. Most of the time from your exam, you'd see this statement that says ignore air resistance. More especially if you project an object vertically. And we know that when the object goes up, there's some air resistance that is being applicable to that object. But now we cannot classify that air resistance as frictional force because it does not act parallel to the surface. So it limits that broader definition of frictional force. So when we say frictional force is the force that opposes the motion and it acts parallel to the surface. So that is why I'm saying that the referee is going to be the exam guideline. So let's define all the terms the way they appear from the exam guideline. So you should not only end when you say that frictional force is the force that opposes the motion, full stop. No, no, no. It is the force that opposes the motion and it acts parallel to the surface. So today you know why do we say it acts parallel to the surface. So a frictional force that we recognize is the one that opposes the motion and acts parallel to the surface. This is how the exam guideline defines the frictional force. And again, I'm saying, seeing these definitions the way they appear from the exam guideline. The exam guideline, it should be your friend. So seeing these definitions, make sure that you sing them the way they appear. So it is important. And then we have two types of frictional force, which is the kinetic friction and the static friction. This is where you end up using this equation. If it's kinetic friction, it's the coefficient of kinetic friction multiplied by normal force. And if it is the static friction, it is the static friction, which is the coefficient of static friction multiplied by the normal force. So, where do we get this information from? From the exam guideline. So let us associate ourselves with the what? With the exam guideline and sing the definitions the way they appear from the exam guideline. Let's move on. Let's move on. So the exam guideline, it then tells you that you should be in a position to draw what? The force diagram. This is what we're going to do. Draw the force diagram and draw what? The free body diagram. So the exam guideline, it tells you that you will be assessed to draw a force diagram or a free body diagram. So draw a force diagram. The exam guideline is telling us that. Draw a free body diagram of all the forces acting on the object. Of all the forces acting on the object. Let's move on. And it even tells you that you will be required to resolve these forces into what? Into components. More especially if we're going to have an inclination, you'll have to resort weight into component. And also force applied, you will be required to resolve it to components. And it does help, more especially when we perform calculations. Once your free body diagram is in components, then you are able to see all the forces that act on that object. Let's move on. Let's move on. I love this. I love this. You'll be required to determine the resultant force. That's what I did say today, that we are going to associate Newton's second law with what? With forces. We are going to associate Newton's second law with force. So the exam guideline, then it tells us Newton's second law of motion. And it tells us how to define it. This is how we should define Newton's second law. That is what the exam guideline is telling us. You define it as when the net force acts on an object, the object will accelerate in the direction of the force. Acceleration is directly proportional to the net force and inversely proportional to the mass of the object. I love this, I love this, I love this. So this is how you sing the definition, the way it appears from the exam guideline. So Newton's second law, we need to be comfortable with defining it because you'll be assessed in paper 1. Question 2, it's Newton's second law. That is why I did say that we will be doing all the topics that are examinable in grade 12. And Newton's laws, they are fully examinable. The first question is to state Newton's second law in words. That is the first question. And you must state it the way it appears from the exam guideline of 2021. That when the net force acts on an object, the object will accelerate in the direction of the force. We are saying that acceleration is directly proportional to the force and inversely proportional to the mass of the object. We are going to unpack this definition. We are going to unpack it. So the exam guideline, it tells us how to define it. And it does emphasize this: draw force diagram, draw free body diagram. So we cannot run away from illustrating force diagram and free body diagrams. Then it says apply Newton's laws. We are going to apply it in terms of calculations using past question papers. So there are scenarios that as a learner you need to familiarize yourself with. Newton's laws is either the examiner will choose a scenario where we have a single object moving on a horizontal plane, either with friction or without friction. Or the examiner can choose one object that is moving on an incline. So you need to familiarize yourself with each and every situation. So here the exam guideline is telling us where the question will arise from. So the examiner will choose either from a single object moving horizontally with presence of friction or without friction, or a single object moving on an inclined plane with or without friction, or a single object moving vertical. So the examiner can choose any scenario here, or the examiner can choose to use body systems which are joined together by a light inextensible string. And you need to bear in mind that once we talk about the string or the rope, something must come to your mind, is that now we're going to have the presence of tension. We are going to have the presence of tension. So examiner can also choose a scenario where we have both system on a flat horizontal plane with or without friction, or one on a horizontal plane and the other one is hanging. More especially the November 2014 question paper, it has this scenario. Or both objects on an incline with or without friction. So the exam guideline is telling you that prepare yourself. One of these scenarios, they will be provided to you in the exam, because now we need to have a giraffe view. That's why we are saying that you are indeed grade 12 of 2022, and already we must think about results that we must pass physical sciences. So we need to employ strategies that will make our lives easier. So the exam guideline is giving us everything that we need. That is why I'm saying that let us use this weapon. Let us use this weapon. So one of these scenarios will be provided to you in question 2 of paper 1. Or both of them vertically hanging. Now, let's get to the topic of the day. I have alluded to you that today we are talking about Newton's second law. Let me come down now. Newton's second law. So we need to build a scientific story using concepts. So let's start by talking about acceleration. So when we talk about acceleration, this is what we have done in grade 10 when you had to deal with motion in one dimension. Acceleration. And I love the way in which you defined acceleration. You said that acceleration, it is the rate of change in velocity. So that's what you said. Acceleration, you define it as rate of change of velocity. And from this definition itself, you can express it mathematically, the rate. When we talk about rate, we are talking about time. So we define acceleration as the rate, meaning that per time, divided by time. Change in velocity divided by time. And where do we get this from? From the definition itself, the rate of change of velocity. So that is what acceleration is. It is change in velocity divided by what? By change in time. So you can express this mathematically, that acceleration, it is change in velocity divided by change in time. We get this from the definition itself. So the definition, it tells us how to define acceleration. Change in this delta means change. Final velocity minus initial velocity divided by what? Change in time. So the SI units for acceleration is meters per second squared. So we need to address this misconception or this careless mistake that learners tend to make. You find that they're calculating for acceleration, but the units are incorrect. They write meters per second. Meters per second, no. Acceleration, the SI units of acceleration are meters per second squared. So I am here as well to emphasize that let us not commit this simple error. It's easy to commit it, but we can avoid it as well. The units for acceleration are meters per second squared. So those are the units for acceleration, meters per second squared. So when you express acceleration, you must put the correct units, meters per second squared. So we are saying that there is a linear relationship between acceleration and the net force. So we do have that proportionality relationship between acceleration and the net force. And strategically so, that's why I'm saying that we have a linear relationship. That must tell you something. So it tells us that acceleration is directly proportional to the resultant force. Acceleration is directly proportional to the net force. That's what we are saying. That's what we are saying. That's why we say that we have that linear relationship. Acceleration, if you increase acceleration, the net force also increases. If you decrease the acceleration, the net force also decreases. So acceleration is directly proportional to the net force. That is very important. It is directly proportional to the net force. So when we talk about the relationship between acceleration and the net force, you must know that they are having a linear relationship. Acceleration is directly proportional to the net force, meaning that when you increase acceleration, also the net force increases. When you decrease acceleration, also the net force decreases. So that is very important. So we should be in a position to understand that. Let us comprehend. We need to internalize that, wow, this is nice. Acceleration is directly proportional to the net force. That is what we are saying. That is what we are saying. Let's move on. So the net force exerted on the object, it causes the change in velocity. So if you are going to exert the force, there was a quick demonstration that was done by my mentor. My mentor did a quick demonstration. She pulled me towards her, lightly so, meaning that she exerted a minute force or small force. And then I did not move much. I just moved like this. And then she pulled me hard. And then I moved faster towards her. And now let us try to look at that example in terms of what we are saying. When she pulled me, she exerted a force. And I moved towards her. So meaning that when she pulled me slightly, I moved slightly. When she pulled me harder, I moved harder. Why? I moved faster because we are saying that acceleration is directly proportional to the net force. So if you increase the net force, it causes the acceleration to do what as well? To increase. So in that instance, that net force that she was exerting, it increased my acceleration. And she pulled me. When you pull someone, she pulled me towards her direction, I moved towards her direction. So the force was in this direction, I moved in that direction. What a beauty of that quick demonstration. So we are saying that acceleration is directly proportional to the net force. So that change in velocity it is what? Acceleration. So she caused me to do what? To accelerate. So that force that she exerted to me when she pulled me towards her, she caused me to do what? To accelerate towards her. So now we are dealing with the content. So I have alluded that yes, indeed, acceleration has that direct proportional relationship with the net force. So this is how we express acceleration. Acceleration is directly proportional to the net force, and it is inversely proportional to the mass, meaning that an object of greater mass will have less acceleration. An object of smaller mass will have greater acceleration. So that tells us that acceleration and mass, they are inversely proportional to each other. Acceleration is inversely proportional to the mass. So we have introduced two things here. Acceleration is directly proportional to the net force. Acceleration is inversely proportional to the mass. So this is how we express that inversely proportional relationship. Acceleration is inversely proportional to the mass of the object. Then, so if you combine both of these statements, then you will see that actually acceleration is given by this expression. Acceleration is directly proportional to F net and inversely proportional to mass. So you'll have acceleration is equals to F net divided by mass. Let's move on. So now it gives us the mathematical expression of Newton's laws. Then let's move on. Let's talk about this, Newton's second law. So how is it that we should define Newton's second law? So we should define Newton's second law as when the net force acts on an object. That is very important. When the net force acts on an object, the object will accelerate in the direction of the force. When she pulled me towards her, I moved towards her. So when the net force is exerted on an object, the object will accelerate in the direction of the net force. And what are we saying? We are saying that acceleration, specifically so, acceleration, you cannot say net force is directly proportional to acceleration. You cannot say that. Let's speak the correct science. We are saying that acceleration is directly because acceleration is directly proportional to the net force. It is directly proportional to the net force and inversely proportional to the mass. There's a reason for this. It is because acceleration depends on the net force exerted and also depends on the mass of the object. So acceleration is a dependent variable. It depends on the net force. When you exert more force, it means that object will have a greater acceleration. So acceleration depends on that. That's why we say acceleration is directly, we cannot say net force. We must say what? Acceleration. Because acceleration depends on the net force. Acceleration is directly proportional to the net force and inversely proportional to the mass of the object. So that is the key word here. The key word is that acceleration is directly proportional to the net force and inversely proportional to the mass of the object. Let's sing this definition to yourself. It's very important. Let's fight to make sure that when it comes to definitions, we get total. 2 marks or nothing. So Newton's second law is saying that acceleration, when the net force is exerted on an object, the object will do what? Will accelerate in the direction of the force. Acceleration, because the one that depends on the force, acceleration is directly proportional to the net force and inversely proportional to the mass of the object. So we can express it mathematical. That says F net is equals to ma. So F net is equals to mass multiplied by acceleration. F net is equal to ma. So when you talk about the net force, it's when we add all the forces. It's the sum of all the forces that act on the object. So that is how we get the net force. So when you say net, we're talking about total. So it's the total forces that act on the object. We add them together. So let's look at this. I think I can give you 2 minutes to perform this one. 2 minutes just to perform this. Right. So now let us respond to these scenarios. I want us to respond to them. So the question is asking us, what will happen to acceleration? We are trying to assess our comprehension of Newton's second law. What will happen to acceleration of an object if, for instance, let's look at A, the mass and the net force both decrease by a factor of 4. So the first thing that you do there, you're going to say A, F net is equals to ma. This is what Newton's second law is saying. It is saying that F net is equals to ma. So you are told that what will happen to acceleration if our net force decrease by the factor of 4 and also our mass decrease by the factor of 4. So now you just need to perform a mathematical expression. So if you transpose this to the other side, you're going to have 1 over 4 times 4 over 1 is equals to A. And then I think your acceleration will remain the same. So in this instance, acceleration will remain the same. And then what will happen to acceleration? Let's look at B. If both mass and the net force increase by the factor of 4. So you write the formula F net is equals to ma. Right? You are told that your net force increased by 4. And then you are told that also your mass increased by 4. So you solve for acceleration. Divide both sides by 4m both sides by 4m. They're going to cancel each other. Therefore, acceleration will remain the same. Can we see that? And then let's go to C. C said, what happened to acceleration if the mass increased by 4 and acceleration decreased by the same factor? So you write the formula. F net is equals to ma. Then you tell us that mass increased by 4 and our F net decreased by 4. So it means you must divide both sides by 4m. Therefore, acceleration is going to be 1 over 4 times 1 over 4. Therefore, acceleration will be 16 times smaller. So it's going to be 16 times smaller. Then let's look for D. For D as well, what will happen if the mass decreased by 4? So what will happen if the mass decreased by 4? F net is equals to ma. The mass decreased by 4, and then the net force becomes 0. So what will happen to acceleration? In this instance, you apply Newton's second law, where you said that acceleration is directly proportional to the net force. So if your net force is 0, it means as well your acceleration is equals to 0 meters per second squared. Why? Because acceleration is directly proportional to the net force, according to Newton's second law. Then let's move on. Multiple choice. I think I've alluded to you that both papers, paper 1, paper 2, you'll have multiple choice questions that you must respond to. So there's a strategy that I want us to use, because we must also get multiple choice correct. It's important to get that multiple choice correct. So number one, you need to understand the question. Don't rush to just say C because your name is Claudia. No. When we deal with multiple choice, read the statement, read the question. That's number one. And fully comprehend the question. What is it that it wants? Does it require you to use a certain principle, or does it require you to perform some calculation? So read carefully the question. And then underline the keyword. What is this multiple choice about? Which topic does it relate to? And then pay attention to the capitalized words, more especially when they say at constant speed. Once we have constant speed, we know that we have 0 what? Acceleration. And usually they'll write it in bold, constant velocity, constant speed. So you look at such terms which are made bolder or bigger, and you look at them, and you need to be in a position to analyze them. What do they mean? So pay attention to those scenarios as well. And then you decide, what does the question want? Does it require you just to recall information? Does it require you to analyze information? Does it require you to do some calculation or use some unit or formula? And then you start to eliminate all the incorrect answers so that you are left with possible correct answers. Then you choose the best answer from there. So it's very important to do this. So when we deal with multiple choice, have a strategy of dealing with the multiple choice. That one need to have it. The strategy of dealing with the multiple choice. Underline the keywords and pay attention to those capitalized words and start to eliminate all the incorrect answers. And you cannot spend 30 minutes on one multiple choice question. You are wasting time. 10 multiple choice questions, they are 20 marks. So spend roughly 20 marks, or 20 times 1,2. I think it's 30 minutes. So give yourself that I'm not going to spend much on multiple choice. There's no use for you to crack for 2 marks for 30 minutes. So here's the question. A wooden block placed on a table is pushed. So here's our wooden block. It is pushed. And when it is pushed, there is force applied. I think in that direction. And it accelerates in that direction. That's what Newton's second law is saying. That when the net force acts on an object, the object will accelerate in the direction of that force. Which one of the following statements regarding frictional force is correct? So you need to recall, what does the exam guideline say about frictional force? Number one, it says define frictional force as force that opposes what? The motion. So if the object is going towards right, frictional force is moving to the left. It moves in an opposite direction. So that is number one. Okay? So that's one thing. And number two, that's why I'm saying that have that exam. It's very important. It's our best weapon. The exam guideline is our best weapon. And then it says that, note that frictional force, number one, it is proportional to the normal. That is what the exam guideline is saying. So if you go to the exam guideline, it tells you that frictional force is proportional to the normal force. That's number one. Number two, it is independent of the area of contact. Number three, it is independent of the speed of the motion. I love this. I love this. This is serious content. This is serious content. So now you start to look at your options. Frictional force is A. Let's look at A. Increasing as the speed increases. Now this one, for us to say that it is wrong or it is not correct, it's because of the exam guideline. Because it says that, note that frictional force is independent of the speed of the motion. It is independent of the speed of the motion. So it makes A to be incorrect. We eliminate it. Okay? B, frictional force is equal but opposite to the pushing force. Chances are it is correct. Yes, frictional force, it opposes the motion and can be in equal magnitude. Frictional force is greater than the pushing force. If we are saying frictional force is greater than the pushing force, then the object must move to the left. So it makes C to be incorrect as well. We're eliminating C. And then frictional force is less than the pushing force. So our possible answer is B or C. Yes, frictional force, it does oppose the motion. But in this case, this object, it was pushed and it accelerated. So it moves towards the direction of the push force. So it tells us that when we compare the magnitude of applied force and frictional force will have less magnitude. So our correct answer in this instance is going to be D. Frictional force is less than the pushing force. So we are just employing those strategies. You can as well do with this one. You can employ such strategies. Carefully read the statement carefully. Look at the words that are capitalized. Understand the question. What does it require you to do? Eliminate all the possible incorrect answers. And I am telling you, you will win. You will win. You will win. So I merely say that let us apply that strategy when we deal with multiple choice questions. Then let's talk about the free body diagram. The exam guideline is telling us that you should be in a position to draw a free body diagram. I am saying to you, you should be in a position to draw a correct free body diagram. Help us with that one. Help us. You must draw the correct free body diagram. You must draw the correct force diagram. Why am I saying that? It is because if your free body diagram is incorrect, chances are your calculation as well will be incorrect. So it is very important to draw a correct free body. Once your free body diagram is incorrect, chances are it's game over. It's game over. Before we even started to do calculations, it's game over. So make sure that you draw a correct free body. We cannot afford to lose a mark when it comes to a free body diagram. And a correct free body diagram, it influences the calculation. So there's a need for me to say this to you. So you should be in a position to distinguish a free body diagram and a force diagram. When we talk about a free body, no body, there is no body. We represent the body of the object by a dot. So that is a free body diagram. We represent the object by a dot. And then the force diagram, you'll have a block. So that is the main difference between a free body diagram and a force diagram. So we are always saying that the normal force exerted, it is always exerted by the surface according to the definition, and it is perpendicular to the surface. So it is exerted on the object by the surface, which it is perpendicular to the surface. So normal force is perpendicular to the surface. So I think it is important for us to emphasize that it is perpendicular to the surface. And when you draw a free body diagram, use the correct symbols. The exam guideline has provided you with some of the acceptable symbols. Normal force is capital letter N. You can see that. Frictional force, small letter f. And then you must have direction. So you cannot just draw forces that do not have what? Direction. So we cannot afford to get a free body diagram or a force diagram incorrect. And all the time you must remember that frictional force opposes what? The motion, and it acts parallel to the surface. That is important. Frictional force acts parallel to the surface. So let's look at this scenario. We are told that the force exerted by the girl on the couch causes it to move towards the door. The frictional force is present between the floor and the couch. Draw a force diagram. That is the key word. Force diagram, indicating all the forces acting on the couch. So that is the key word. We don't draw a free body. We are drawing what? A force diagram. And a force diagram, we are going to represent this object with a what? With a block. So this system will be represented by what? By a block. So that is the difference between a free body diagram and a force diagram. So let's look at the solution. So you're going to have your block like this. The girl was pushing the couch in that direction, meaning that force applied is towards that direction. That is why the couch is moving in that direction. It means we're implying Newton's second law. When the net force acts on an object, what will happen? The object will accelerate in the direction of that force. So because the girl is pushing it that way, that is force exerted. So it means this object will accelerate in that way. So now the first thing that you do, then you illustrate your normal force. Remember, normal force is the force exerted by the surface. So it starts from here. Usually we'll see learners drawing a normal force starting from the middle. So we are trying to fix that misconception. Learners, please don't commit mistakes here. The normal force, it starts from the surface. It's the force exerted by the surface. And it acts perpendicular to the surface. It goes up. And then we'll have the force of gravity. That is always going where? Downwards. The force of gravity is always going straight downwards. From the center going down. And then we did say that the lady is pushing the object towards the door, meaning in this direction. This is what we picked up. So force applied will be in that direction. And we are saying that the frictional force opposes the motion. It means frictional force will act in that direction. Frictional forces will act in that direction. And it acts parallel. It acts parallel to the surface. So frictional force exists between the surface and the object. That is why we draw the frictional force here. So this is the force diagram of that scenario, which is 4 marks. Every force carries a mark. So make sure that you have arrows so that you get all the marks. And use acceptable symbols. As well, we can have a scenario where we have a normal on an inclined, or we can have a situation where we have force applied at a certain angle. And you'll be required to draw a force diagram. And again, we are saying that your normal force must start from the surface and it goes up. And then the force of gravity starts from the center, it goes down. Now, this one, the force applied, it is applied at the angle. So you indicate that it is applied at the angle. Frictional force, if it's horizontal, it will oppose the motion. And we can express this using a free body diagram as well. So a free body diagram, you will represent the object with a what? With a dot. And we're having a horizontal plane. So it means our normal force is going up. And our force of gravity is going down. And then you'll have the applied force at a certain angle. And then you'll have the frictional force in opposite direction. So that is very important. And you can resort these two components of force applied, where we can say we have the normal force, which is the normal force, the force of gravity. Now, when you resort these two components, then you'll have f of y and you'll have f of x. Then you'll have what? Frictional force. So you can resolve these two components. So that is what we are saying. You can resort these to what? To components. So you should be in a position to separate the force diagram and a free body diagram. So here is a situation here. It says calculate the coefficient of the kinetic friction if a 2 kg box is pulled with a horizontal force to the surface. The kinetic friction between the box and the surface is 5 newtons. So you look at what you are given, write your data down. You are given the mass of the box. The question wants you to calculate the coefficient, and then you have the kinetic friction. So it means you are going to use this equation that says kinetic friction is equals to the coefficient multiplied by the normal force. So this is the formula that you'll use. And what is our normal force? On the horizontal, normal force is equal to the force of gravity. So meaning that normal force is equals to mg in opposite direction. Then you substitute. When you substitute, our kinetic friction is 5, our mass is 2, our gravity is 9.8. And then you solve, you get the answer. So that is very important. This is very important. So I am going to give you 5 minutes to deal with this question. 5 minutes. Now, I am interested in your response. Let us try to tackle this question together. And bear in mind that all the time, me and you, we are a double tech team. We are dealing with this content. We need to fight it and make sure that we pass. Because now we are focusing on getting good results. You are already in the zone of grade 12. So we are no longer slacking behind. Let's look at this. A 10 kg box is placed on a table. A horizontal force of magnitude 32 newtons is applied to the box. Frictional force of magnitude 7 newton is present between the surface and the box. So this is what we have. Have your data down. Write it down, your data. We have force applied. We have frictional force. So the first question says, draw a free body diagram. Maybe this is 4 marks. Draw a free body diagram. A free body diagram. And if you see the mark allocation there, it says 4 marks. It means that the number of forces acting on that object, they are 4. If it says 5 marks, it means the number of forces acting on that object, they are 5. So the mark allocation, it signals the number of forces acting on that object. So that is what the first question is saying. Draw a free body diagram. So here is our box. The force is applied in that direction. Now, the difference between the free body diagram and the force diagram is that free body diagram, you represent it with a what? With a dot. So our surface is horizontal. So you start by showing us your normal force. This is where you start. You show us your normal force, which acts perpendicular to the surface. And then you'll have your force of gravity. And force is applied in that direction, so that is force applied. Meaning that frictional force will oppose the motion, and then you'll have frictional force. So this is a free body diagram. So when you deal with a free body diagram, you represent it with a what? With a dot. And always know that normal force, it's perpendicular to the surface, and it always goes upwards. Force of gravity, it goes down. So it's 4 marks, 1 mark for each force. So let us be in a position to draw a correct free body diagram. Then the subsequent question said, calculate the acceleration of the box. So you will apply Newton's second law, F net is equals to ma. When you apply this one, you must have a direction in mind. Where the object is going, take that as positive, strategically so. Where the object is going, take that as positive. So the object was going in that direction, the box. So let right be positive. Meaning that everything that goes to the left becomes negative. So net means total. So we must add all the forces that act on the object. And it's what? According to our free body diagram, this is what we had. Normal force, force of gravity, applied force, and frictional force. The normal force is equal to the force of gravity, but in opposite direction. So it means they cancel. So we are left with 2 forces, which is what? Which is force applied plus frictional force is equals to ma. So our force applied is going to the right, so it becomes positive, force applied, plus of this formula. Our frictional force is opposing the motion, so it becomes negative, is equal to ma. Then we express it mathematically. Positive times negative is negative. Frictional force is equals to ma. Once you have this, then what do? You substitute. Let us not be obsessed about getting the correct answer. Let us be obsessed about copying the correct. It's a skill. Copying is a skill. You are doing a wonderful job if you can copy legally, not illegal, legal from the formula sheet. So copy the formula and substitute correctly. You have 70% of the question. So this is where marks are. The correct formula and substitution. So what is our force applied? We are told is 32 minus, what is our frictional force? 7 equals to, what is our mass? The mass of this box is 10. What is our acceleration? Unknown. 32 minus 7, I think it's 25, is equals to 10a. You solve for acceleration, divide both sides by 10. I think acceleration will be 1,2 meters per second squared. We can verify that. We can verify that. As well, you can punch your calculator while I do as well. Punch your calculator and verify. So this is what we mean. So when you say 25 divided by 10, I think you're going to get 2,5. So pardon me about that. So it's 2,5. Then calculate the normal force. We are saying that normal force is equals to Fg. So normal force is equals to mg according to our free body diagram. So what is your m? It's 10. What is gravity? 9,8. And I think your answer will be 98 newtons. So it's 1 mark of the formula, 1 mark for substitution, 1 mark for the final answer. And then let's move on. So here we are having a scenario again. Let's look at this scenario. It says an 8 kg block P is pulled by a constant force up. So this is force exerted or force constant. Up a rough inclined plane at an angle of 30 degrees to the horizontal at constant speed. At constant speed. So you must bear in mind at constant speed. If we don't have any change in speed, it means our acceleration is equals to 0. So the force F is parallel to the inclined plane as shown below. Then we are told that the coefficient of kinetic friction is what? It's 0,30. Calculate the magnitude of force F. So now we apply the skill. The first thing that you do, draw the correct free body diagram. Because if it is wrong, then the calculation will be wrong as well. You represent this 8 kg by a dot. This is what you do. And our surface is on an incline. Once the surface is on an incline, it means we must resort to components of gravity. But we are saying that normal force is perpendicular to the surface. So this is how the normal force will be. It forms a straight T with this surface. With this surface. And then the force of gravity is going down. And then we have this force that we want. And it moves up a rough. Once you see the word rough, then you must understand we have presence of friction. Small letter. Now, we are having an incline. We resort to components of gravity. This one is a tip for free. Don't even prove it. We are going to grade 12 now. Don't prove it. Now, when you resort to components, we are going to have Fg perpendicular. The force of gravity is always going down. And we are going to have Fg parallel. And I'm saying to you, Fg perpendicular is equals to mg cos theta. Fg parallel is equals to mg sin theta all the time. So it means normal force will be equal to the force of gravity perpendicular. They cancel each other. So you'll be left with 1, 2, 3 forces. Then you perform your calculation. You choose your direction. Where is the object going? It's going up. Let up be positive. Anything that goes down, it becomes what? Negative. Then you say F net is equals to ma. So that's what you do. F net is equals to ma. F net is equals to 0. Why 0? Because we had constant speed. Once we don't have any change in speed, it means our acceleration is what? It's 0. How many forces were left? Let's go to our free body diagram. It was 1, 2, 3. So F net is 1, 2, 3, which is force F. The reason why it becomes negative, it is moving in an opposite direction. It's going down of the force of gravity parallel, as well as the frictional force is going down, is equals to 0. Then what do? You substitute and you get your answer. What's important about this, what I'm trying to show you here, is that you get 1 mark for the formula. 1 mark for substitution here, 1 mark for substituting here, 1 mark for substituting here. So you have 80% of this question. Even if your answer is incorrect, but if you copy the correct formula and you substitute correctly, you have all the marks. And then your answer is only 1 mark. So why would you care about 1 mark? Let's fight to get maximum marks. Then after, we can care about getting the correct answer. So that's one scenario. As we have said, that the examiner can choose any scenario that he or she wants. So here's a question. I'm left with 5 minutes. You'll have to bear with me. I hope that I'll be in a position to perform this calculation fast. A learner constructs a push toy using 2 blocks with mass 1.5 kg, 3 kg respectively. The blocks are connected by a massless inextensible string. The learner then applies the force of 25 newtons at the angle of 30 degrees to the 1.5 kg block by means of a light inextensible rigid rod, causing it to move on a flat rough. So it tells us that we have presence of friction. So the coefficient of kinetic friction between the surface and each block both blocks, they experience friction. For each block is 0.515. So calculate the tension of the cord, 6 marks. So you apply the very same strategy. Draw a free body diagram. We have 2 bodies here. So it means you must have 2 free body diagrams. So I'll separate this. Here we'll have the 3 kg. Here we'll have the 1.5 kg. So for 3 kg, we represent it with a dot. Our surface is horizontal, so normal force is equals to the force of gravity. And if you look at this picture, the image is that where the rope is, that's the direction of the tension. So for 3 kg, tension is on the right. So we are going to have tension. And this object, remember, there was force applied causing it to move in that way. So it means that frictional force will go in an opposite direction. So this is the free body diagram that we have. Then we can say, let where the object is going, let right be positive. You write the formula, F net is equal to ma. F net, total number of forces. Tension is going to the right, it becomes positive. Frictional force, it becomes negative because it's going to the left. Is equal to, what is your mass? It's 3, and we want acceleration. So we don't know what is our tension, we can find frictional force, where we can say kinetic friction is equals to UK multiplied by normal force. So you can say 0.15 multiplied by mg, which is 3 times 9.8. And I don't know what would be your answer. You are going to get 4.41 newtons. So here you are going to get 4.41 is equals to 3a. So you can make this equation 1. Let's come to 1.5 kg. F net is equals to ma. Draw a free body diagram. Before you come to this, you are going to have the normal force and the force of gravity. Now, there was force applied. So you resorted to components, which is F of y, because it's going down. That applied force is going down. So F of y, it goes down. And we are going to have F of x. And as the object is going to the right, it experiences what? Frictional force in opposite direction. So this is the situation that we have. Then you can say F net is equals to ma. So you can see that 2022 grade 12 learners, we don't have much time. I so wish that you continue with this calculation and we compare our answers online, because I'm within your reach. Let us continue to have these conversations. Science should never end. See you next time when we deal with electrostatics. See you next time. Thank you, thank you, thank you.